What makes cold solder joints fail in robotics projects? Imagine building a robot that suddenly stops responding or acts erratically. One common culprit behind such issues is a cold solder joint. These joints happen when the solder does not melt enough to bond properly with the metal surfaces. When soldering for robotics projects, building and prototyping, a weak joint can cause sensors to flicker or motors to cut out unexpectedly. Cold solder joints mainly fail because the solder does not heat up enough during the process. If the soldering iron is not hot enough or not applied long enough, the solder won't fully melt. This results in a bond that looks dull and cracked instead of shiny and smooth. Proper heating is key to creating a strong connection. Another big factor is surface contamination. Dirt, oil, oxidation, or leftover flux can stop the solder from sticking well. When surfaces are dirty, the solder beads up instead of flowing into the joint. This creates gaps or weak spots that can crack or break under stress. Always clean the component leads and PCB pads thoroughly before soldering. Using the right technique is also important. Setting the soldering iron to the correct temperature, usually around 350 to 450 degrees Celsius, helps. Applying flux helps clean the metal surfaces and promotes better flow of solder. Moving the soldering iron too quickly or removing it before the solder cools can cause cold joints. Patience and steady hands are essential. Robotics projects often involve vibration, movement, and temperature swings. These stresses can cause a cold solder joint to crack over time. Mechanical stress weakens the bond, especially if it was not solid to start with. Reinforcing joints with additional solder or mechanical supports can help prevent failure. Using too little solder or uneven amounts can leave gaps or weak spots. Always apply enough solder to cover the joint fully, but not so much that it creates blobs. A good solder joint should look shiny, smooth, and slightly concave. If it looks dull, cracked, or rough, it might be a cold joint. To avoid these problems, set your soldering iron to the right temperature and give it time to heat the joint thoroughly. Clean all surfaces before soldering to remove oxidation. Use flux generously to help the solder flow. Keep the joint still until the solder cools and solidifies. Inspect each joint visually to ensure it looks good. If you notice a dull or cracked joint, reheat and add more solder if needed. In robotics building and prototyping, reliable soldering is essential. Cold solder joints can cause intermittent issues or complete failures. By understanding what causes these weak connections and following proper soldering techniques, you can make sure your robot's electrical connections stay strong and dependable through all the vibrations and temperature changes it faces.